Okay, so I thought I would take this problem and give you guys a look into how I think about these problems. Part of it is because you like to jump to numbers right away. And you're going to be that way for a while until eventually you get to a point where you're like, oh, the numbers actually make it harder. The concepts are all in the variables, not in the numbers. So let's take a look at this problem. Another thing you guys do is you do not write down the equation you're going to be using. And that leads to careless mistakes. It also, in the next couple of weeks, we're going to start with, you're going to write down the equations first, and then you're going to start working the problem. The reason for that is when you take the test, the rubric is, give me the equations that you're going to use for this problem, give me the units, and now solve the problem. So we're going to look at what I do when I look at this. Here we have, on this problem, we have an acceleration vector. We know at time t equal to 0, it is at rest, so the initial velocity is 0. And we know it is at the origin, so the initial displacement is 0. So we know then that the velocity, well, I'm going to put initial is 0. And we know that the initial displacement is 0. What is the equation that we're going to be using for this? Well, it was one of the two I gave you on the to write up, right? We've got the initial displacement plus initial velocity times time plus 1/2 of the acceleration vector times time squared, right? That's the equation I gave you. This is the starting point. We already know R naught, we know V naught, and we know A because it's given up here, right? So A is 1 point, I'm going to put the parentheses in, so 1.5 I hat plus 6.66 J hat meters per second squared. Yes, my typos. Okay, and significant digits there, 1.50. So we know all of these, and we know the time is 2.00 seconds, right? So there you go. That's everything. All right. Here is often you guys are going to make some sort of mistake by not being careful and meticulous like this. All right? On the test, I'm going to be looking for this equation right there. That's the equation you're going to be using. And then you're going to want to make sure you put in what are my initial values everywhere. All right, that's not part of the rubric, that's part of working the problem, but you put in your initial values. And so if we do this, then we're going to get R, all right, is going to be 1.50 I hat plus 6.66 J hat times to time is 2 squared, and at the end of the day, that's all going to be meters. So we got 4 times 1.5 and 4 times 0.66. Let me just pull up Excel real quick. That's going to be 6, and 4 times 6.66 times 26.6. Okay, so this is going to be 6.00 meters I hat plus 26.6 meters J hat. All right, that's the displacement vector. What is the displacement from the origin at t equals 2 seconds? So the displacement from the origin is just going to be d, which is the magnitude This would be another equation you would need to include in your equations, right? Magnitude of r, not hat, r vec, which is going to be square root of r sub x squared plus, woo, plus r sub y squared okay, so square root of 6 squared, so 36 plus we'll just go ahead and do this, 6 squared plus 26.6 squared. My units at the end of the day are going to be meters, right? Because I got meters squared underneath the square root, and that comes out to meters. So I'm going to go back to Excel real quick. 6 squared, 710, so 36 have 710, so the square root of 36 plus 710, 27.3. Okay, 36, 710, 27.3. 27.3 meters. I'm just going to go ahead and do that. So, when you work these problems, the more time you spend being careful and more explicit about what you're doing, the better off you'll be. Don't rush to just throw in numbers, because when you rush to throw in numbers, you start making mistakes. Don't forget to put in I hat and J hat, because when you start dropping those, you make mistakes. So keep in your vector components, keep those in until they actually go away when you're calculating a magnitude. All right? Okay, hopefully this helps. I'll see you in class.